In this video, we're going to look at a couple extra functions and talk about some of their properties and how to work with them. So first we consider the function f of x is 2x squared minus x minus 6. So the first thing we want to think about is, what's the domain? So remember, the domain is allowable x values. So when you're thinking about domain, you want to think, are there any x values I cannot plug in? Okay, now here there's none because f of x is a polynomial, and all polynomials have domain of all real numbers. So sometimes we write that as a boldface R, or you could write minus infinity to imply that that's the interval of the domain, so all x's are valid. Or you could write all real numbers, or you could write x is between negative infinity and positive infinity. Okay, all of those say the same thing. Now f of 2, what this means is that the x value is equal to 2. So all you have to do here is plug in x equals 2. So this is 2 times 2 squared minus 2 minus 6. So 2 times 4 is 8 minus 2 minus 6. So it's 8 minus 8, which is 0. Okay, so here f of 2 is equal to 0. Now, what about the x and y-intercepts? Okay, the y-intercept is normally easier. This is when you set x to 0. Okay, so that's actually f of 0. Okay, so here we would write 2 times 0 squared, or you could write y equals 2 times 0 squared minus 0 minus 6. That's going to be minus 6. So that means that the y-intercept point is 0 minus 6. Okay, for the x-intercept, we set y to be 0. Okay, so when y is 0, that means we want to solve when 0 equals 2x squared minus x minus 6. Now we already got that f of 2 was equal to 0, so actually 2 is going to be an x-intercept. But we could factor this because I think there's probably going to be more than one. So we want two numbers that multiply to 2 times negative 6, so negative 12, and add to negative 1. So that's going to be negative 4 and positive 3. Okay, so we're going to factor this. So I split up the middle term to be minus 4x. Oops, okay, nope, never mind. Plus 3x minus 4x minus 6. It doesn't actually matter which way you put those two. Okay, so maybe I'll just highlight here. So this minus x became plus 3x minus 4x. Notice that simplifies to minus x. And then we use the factor by grouping. So we're going to group these two, pull out what we can. So at the first terms, I can just pull out an x, and I'm left with 2x plus 3. And then the next term, I can pull out a minus 2, and then I'm left with 2x plus 3. So now I can pull out 2x plus 3, and then I'm left with x minus 2. Okay, so that means that either 2x plus 3 is equal to 0, or x minus 2 has to be equal to 0. So when you have two numbers multiplied that equal 0, it means that one of the numbers has to be 0. Okay, so either 2x plus 3 is 0, or x minus 2 is 0. And if we solve each of these, the first one says x is negative 3 over 2, and the second one says x equals 2. So notice we got that 2. So this tells us that the x-intercepts, and we have two of them, is negative 3 over 2 and 0, and 2 and 0. So now this is actually similar to part B. So we want f of x plus 1. So this one maybe is a little bit confusing because there's an x in there. But essentially what it means is you replace all x's with x plus 1s. Okay, so here in this one we replaced all x's with the number 2. Okay, so here we're doing the same thing except we're replacing it with something that's more complicated than a number. So we're going to have f of x plus 1 is 2 times x plus 1 squared minus x plus 1 minus 6. So remember, everywhere we had an x, we now have an x plus 1. So if I go up here, there's an x, there's an x. So I put in x plus 1 into each of those spots. And then we can simplify this a bit. So this is 2 times x squared plus 2x plus 1 minus x minus 1 minus 6. Simplifying and combining like terms gives me 2x squared. 4x minus x is plus 3x. And then I have 2 minus 1 minus 6 is going to be minus 5. So that is my f of x plus 1. Okay, now we're going to do something very similar, but so a little bit more involved here. So we have f of x plus h minus f of x all over h. Okay, this is actually going to mean something for us in chapter 1. So it's very important that we know how to do these. So my new x for this first one is f of x plus h. So it's x plus h. So everywhere I see an x in my equation, I have to put in x plus h. So f of x plus h is going to be 2 times x plus h squared minus x plus h minus 6. And then I want to subtract f of x as it was, and then divide all of that by h. Okay, so this part is f of x plus h, and this part is my f of x function. And now I just want to simplify. So I have to simplify as far as possible. So I'm going to expand it all out. So it's going to be 2 times x squared plus 2xh plus h squared minus x. This should be a plus. So this should be a minus. Minus x minus h minus 6 minus 2x squared minus negative x, so plus x, minus negative 6, so plus 6, all over h. And then I'm going to expand that 2 through to everything that's in the brackets. So it's 2x squared plus 4xh plus 2h squared minus x minus h minus 6 minus 2x squared plus x plus 6. And now I'm just looking for like terms. So I have 2x squared and I also have a negative 2x squared. So those actually disappear. I have a minus x, but I also have a plus x, so those disappear. And I have a minus 6, but I also have a plus 6, so those are going to disappear. So what I'm left with is 4xh plus 2h squared minus h, all over h. And I can see now that I can factor out an h on the top. And then I'm going to have 4x plus 2h minus 1 all over h. H over h is 1 as long as h isn't 0. So now I've simplified this to 4x plus 2h minus 1. And that's as far as I can go. So that's what f of x plus h minus f of x all over h simplifies to. Okay, so all of that was with a quadratic function. Okay, what if I have a square root? So we're going to do all the very similar things. So what's the domain of this? So because it's a square root, we need the thing inside the square root, so 5 minus 2x, to be at least 0. So if I solve, so I'm going to add 2x on both sides. So that means that 5 is bigger than or equal to 2x. And then I can divide by 2 on both sides. So that means that x well, okay, sorry, let me keep it in the same order. 5 over 2 is at least as bigger than or equal to x. Now remember, if you move the 5 over, you're going to have to divide by a negative 2. When you divide or multiply by a negative number, you have to flip the inequality. Okay, so this is the domain in interval notation. Okay, we want everything that's less than or equal to 5 over 2. So 5 over 2 is the biggest thing, which is 2.5. But then we can go all the way down to negative infinity. Okay, so the round bracket does not include that endpoint, and you can never include infinity because it doesn't exist. Here we do want to include 5 over 2, so we use a square bracket. So that would be the domain in interval notation. Okay, so now we want f of negative 2. Negative 2 is in the domain, so we can plug in x equals negative 2. So remember, we want to replace all the x's with negative 2. So f of negative 2 is equal to the square root 5 minus 2 times negative 2. So that's the square root of 5 plus 4, which is 9. So that's going to be 3. Now, if you look at parts C and D, they look fairly similar. The difference is where these brackets are. Okay, so here we want f of x squared, and then we subtract the negative 3 after. So you want to compute f of x squared and then minus 3. In part D, we want f of x squared minus 3. So we're putting this whole thing into the function. Okay, so there's a difference here. So in this one, f of x squared minus 3 is going to be f of x squared, so 5 minus 2 times x squared. So put in x squared whenever you see an x. Okay, and then I have to subtract 3 on the outside. Okay, so this is square root 5 minus 2x squared minus 3 on the outside. Okay, now if I have it all inside, this is my new x. Okay, so this whole thing is the new x. So this is going to be the square root 5 minus 2 times x squared minus 3, which we could simplify. The 2 can go in. It's going to be 5 minus negative 6. So it's going to be 5 plus 6 is 11 minus 2x squared is what that would simplify to. Okay, now we're going to try another one that looks like what we did before. So f of x minus 2, h minus 2, minus f of negative 2 all over h. So f of h minus 2 is 5 minus 2 times h minus 2. Okay, minus, we did f of negative 2, so I don't actually need the square root. Okay, we know that that's 3 all over h. Okay, so this square root is f of h minus 2, and this number 3 is f of negative 2. So we can simplify. So this is going to be 5 plus 4 is 9 minus 2h minus 3 all over h. Now here, when we want to simplify, so this is fairly simplified, but in the chapter 1, we're going to need to get rid of this h on the bottom. Okay, so what we're going to do here to simplify this a bit better is rationalize the numerator. So remember, when you do that, we want to multiply by the conjugate. So that's the same two things. Okay, whatever we do to the top, we have to do to the bottom. Okay, but with a different sign in between. So when we do that, I'm going to get square root 9 minus 2h all squared. And then, so that's this part. And then when I do the outer ones, I get 3 times that square root. And the inner ones, I get minus 3 times that square root. So those ones are going to cancel. So then I just have minus 3 times 3, or minus 3 squared. On the bottom, because I want to cancel that h, I'm going to leave this without expanding. Okay, so then on the top, the square root goes away, so we get 9 minus 2h minus 9 all over h times square root 9 minus 2h plus 3. Okay, 9 minus 9 goes away, and then the h and the h can cancel. So I'm going to have negative 2 over square root 9 minus 2h plus 3. And this is how we're going to want to leave our answer. Okay, so this is just a bit of extra practice with functions, in particular the domain, and then the function notation. Okay, so using function notation and what it means.